Hello students, this is lesson U1A01. In this lesson I am going to go over exercise U1A01a, which is an exercise on solving system of two linear equations. Now I know this is not the first time that you guys are seeing this, which is why I'm going to go through this a little quickly, summarizing a lot of key ideas in this video. So let's take a look. Alright, so the first problem number one, I'm only going to go over only the odd questions in this exercise, version 2 of this exercise. So if you look at the instructions here, it says to solve each system by graphing. So let's do that, okay? So when we're solving a system of equation, okay, what we're doing is we're looking for a common point of intersection. So by looking at the first equation there, I noticed that it's written in slope-intercept form, which allows me to easily graph equations. So I want to start off by plotting the y-intercept, which is 4. And then I have a slope of negative 1/3, which means I'm going to go down 1 and over 3. And then down 1 and over 3. I don't have enough graph moving in the to the right there, so I'm going to draw another point in the opposite direction. So this is the line being described in the first equation. All right, in the second equation, I have y equal to 7/3 x minus 4. So we have a y-intercept of negative 4, and I have a slope of 7/3, which means we're going to go up 7 and over 3. So, which means that's just going to be this point right there. So I've located my first point. It's located at 3, 3. All right, let's take a look at the next one. So the next pair of equation that I have is y equal to 3/4 x minus 1. So I'm going to approach in the same manner. I noticed that the y-intercept is negative 1, and I'm going to go up 3 and over 4. So it's going to go look like this. Okay. And my second equation is going to be positive 4, y-intercept of positive 4, because I don't have any space over here. I'm going to draw in the opposite direction. So instead of going up 3 and over 4, I'm going to go down 3 and to the left 4 and so forth. And as you can see here, we do not have a point of intersection. As a matter of fact, these two lines are considered to be parallel. And we already knew that walking into the problem, because upon observation here, notice that the slopes are equal. Anytime that you have equal slopes, the two lines are automatically going to be parallel. So because of this, we say that there is no solution. All right, let's take a look at the next one. So for the next couple questions here, we are going to try and solve the system algebraically, either by elimination or by substitution. So let's take a look. Notice that right now I have y is equal to 1, and I have the equation here, x plus y is equal to 3. I am not going to solve this by elimination. I'm going to solve this by substitution just because it's super convenient. I already know what y is. So therefore, I'm going to take this and substitute it in there, and what I'll get is x plus y is equal to 3. And now I can solve for x. Subtract 1 from both sides, I get x is equal to 2. Moving on. All right, so this is actually set up prime for using the method of elimination, because if you notice right now, all the x's and all the y's, they're all lined up, right, correspondingly. So I have an x column and I have a y column, and what I'm going to do is I'm going to eliminate some variables here. So what I'm going to do is I'm going to take all of this, okay, and I'm going to subtract it. I'm going to take this top equation and subtract it by the bottom equation. So I put parentheses around the bottom equation just to emphasize that that negative symbol will need to be distributed throughout that bottom equation there as I perform subtraction. So I'm going to do 3x minus 3x, so that will be 0. And then I have 2y minus 2y, so that will be plus 0 again. And then 8 minus positive 6, which is then going to be 2. Does 0 actually equal to 2? Of course not. 0 does not equal to 2. So what does this mean? This means that there's no solution. So this is an algebraic interpretation of what took place in question 3, okay, from before. What does this even, why is it no solution, right? Well, the reason why it's no solution is, well, if we solve for y, right, or rather if we try to find out what is the slope of this equation here, right, I'll end up with 2, I'm going to subtract both sides by 3x. I'll end up with negative 3x plus 8, and divide by 2. I'll end up with negative 3 halves x plus 8. And if I do this with the second equation, you'll notice that we'll actually end up in, I'm sorry, this should be 4 here, not 8. We'll end up in the same, with the very similar equation. We're going to end up with negative 3 halves x plus 2. So again, looking at these two equations, we're going to see that we actually have two equations with the same slope. So anytime that you have linear equations with the same slope, you automatically know that same slope but different y-intercept, that is. You automatically know that we're going to have no solution because the lines will end up being parallel. Let's take a look at the next one here. All right, so now this equation here, it's really not set up for substitution or elimination. And quite frankly, to be honest with you, a lot of times, in my opinion, it is actually easier to solve system of equation by elimination. And the reason why I say that's easier, in my opinion, again, I know that's very subjective, is because I feel that elimination method helps the person solving the problem organize their thoughts a little better over substitution. Sometimes substitution, we tend to overlook a step, and sometimes we tend to we forget to distribute a negative. I mean, it can happen with elimination as well, but I just, in my opinion, I think it's just a little more organized. So I want to solve this by elimination, actually. So what I'm going to do is I'm going to set this up. I'm going to arrange this so that it's 4x plus y is equal to positive 3. I'm going to arrange it so that I have, so that the equation is written as x first and then y equal to some number. And I'm going to do the same thing with the second equation. I'm going to bring the 8x over. So I'll have negative 8x minus 2y is equal to negative 6. All right, so at this point here, I'm set up to solve this by elimination. I am going to, what I need to do, if you recall from days of Algebra 1, right, we need to have the coefficients of the variable that you're trying to eliminate, okay? We need to have the coefficients be the same value but of opposite signs, okay? So I'm going to make the choice. I'm going to make a choice to either eliminate x or eliminate y. So in this case, I'm actually going to make a choice to eliminate y, okay? So what am I going to do? I'm going to multiply the top equation by positive 2. So if I do that, I'll end up with 8x plus 2y, because again, I'm multiplying the top equation by 2. 8x plus 2y is equal to positive 6. And then the bottom equation is negative 8x plus 2y, minus 2y is equal to negative 6. And then at this point here, what I'm going to do is I'm going to add the 2, okay? So if I do that, I'll end up with 0 plus 0 is equal to 0. Does 0 actually equal to 0? It certainly does. Now, what's the interpretation here? The interpretation is this. We actually have infinite solutions. Why are there infinite solutions here? Well, the reason is the bottom equation, if you notice right now, we can actually rewrite this slightly differently. Notice that the bottom equation has a common factor of -2 all throughout. If I were to divide both sides by -2, let's see what happens. I'll end up with 4x plus y is equal to +3. Wait a minute, isn't the bottom equation the same exact equation as the top equation? It certainly is, right? So actually, if you look at this, right, I'm going to rewrite this again. This is y is equal to -4x plus 3, right? The y-intercept is 3. The slope is -4. I want to rewrite this in slope-intercept form. So again, this is y is equal to -4x plus 3. We have the same slope, but not only the same slope, but the same y-intercept. This is actually, these two equations are the same line. So the two lines are one on top of the other, which is why we say there's an infinite number of solutions, because they are forever intersecting, right? That's one way of interpreting it. Let's take a look at the last one here. So I am going to, again, set this up for elimination. So I have -3y plus 2x. Notice I did not write x and then y. You can actually write it in either order. It really doesn't matter. I'm going to bring all the x's and y to the other side. So I have -3y minus 4x is equal to 6. And this is already set up for elimination, because if you notice, the coefficients for y are identical. All I got to do now is just multiply the bottom equation by negative and add, right? So I'll end up with -3y minus 3y minus -3y. That's just 0. 2x minus -4x. Well, when we're subtracting, that becomes a plus, right? So that's 6x. And then -12 minus 6, that will be -18. Divide both sides by 6, I'll end up with x is equal to -3. We need to now go back in and solve for y. So what if x is equal to -3, I can substitute this into either equation. So it looks like this difficulty level is really no different. So I'm going to substitute into the first equation. So I have -3y plus 2 times -3 is equal to -12. So therefore, -3y minus 6 is equal to -12. I'm going to add 6 to both sides. I end up with -3y is equal to -6. Divide by -3, I'll end up with +2. Y is equal to 2. And that's it.